Hey everyone, welcome back. This is lesson 7.3, Logarithmic Functions. Your objectives for today, you'll be able to write equivalent forms for exponential and logarithmic functions, and you'll be able to write, evaluate, and graph logarithmic functions. Your vocabulary for today is logarithm, common logarithm, and logarithmic function. All right, so before we get started, I want to just do some review on exponents with you. Let's remember 4 to the negative 3 power doesn't mean a minus. It actually means to take the reciprocal of our 4, and we're going to have that raised to the third power. So 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. So there's our first answer. Remember, 16 to the 1/4 power, that really means to do this. All right. And 16 can be broken down into 2 times 2 times 2 times 2, and there's actually 4 of them, and that's what we're required, so the answer is going to be 2. All right, for our 10 to the negative, again, that means 1 over 10, and 10 to the 5th power is going to equal this. All right, and then next we have 2/3 raised to the negative 3. Again, that doesn't mean minus, it means do the reciprocal. So we're going to say 3 over 2, and that is going to now be to the third power. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. And there's our answer. All right, so just seen it in words, a power has a base of -2 and an exponent of 4. Write and evaluate the power. So you should write something like this. -2 raised to the 4th power equals 16. And finally, number 6 is 2 to the 3rd power. We know is the same as 2 times 2 times 2, which is 8. Very simple. All right, so let's look at some of these problems. In the first problem, I have 5x equals 50, and if I'm asked to solve this problem, I want to end up saying x equals something. All right, so my problem is going to say x equals something. And when I look at this, I say 5 is multiplied by my x, so I need to undo that multiplication. And I can undo my multiplication by the inverse of it, which would be divide. So if I divide both sides by the inverse, I can end up with x equals 10. All right, because this becomes 1. All right, in my next problem, I see that I have my x, but I have a 35 added to it. So I want to undo that addition or subtract. So I want to do the inverse, so minus 35. If I do that on one side, I have to do the other. Simple. X equals 10. All right. Here I have my x is divided by 5, so the inverse, I want to undo this division here, so I'm going to multiply both sides by a 5. And when I do that, I end up with x equals 35. So in each of these problems, I looked for the inverse to undo whatever was being done to my x so I could get x by itself. But then when I look at this next problem, 3 to the x power, I'm not really sure how to undo an exponent. All right, I can guess and check. I can say, well, I know 3 to the 0 power equals 1. And I know 3 to the first power is 3. I know 3 to the 2nd power is 3 times 3, which is 9. And I know 3 to the 3rd power then is 3 times 3 times 3. Well, that's 27. Yay, I found it. So 3 to the x in this case would equal 3. But what do I do when I get to a problem like this? 2 to the what power equals 52. Man, I'm going to be writing and guessing and checking a lot before I get to 512. So what should I do? Well, there seems to be, there could be some kind of something inverse for my exponent that would help me find that. And in fact, there is. In mathematics, the logarithm is the inverse operation to exponentiation, just as division is the inverse of multiplication and vice versa. That means the logarithm of a number is the exponent to which another fixed number, the base, must be raised to produce that number. In the most simple case, the logarithm counts repeated multiplication of the same factor. Example, 1,000 equals 10 times 10 times 10 equals 10 to the 3rd. So the logarithm to base 10 of 1,000 is 3. You can write an exponential equation as a logarithmic equation and vice versa. You read this as the log base b of a is x. All right, so for today's lesson, you're going to need to be able to convert one format to the other. So we're going to be taking this format and changing it over to this format or vice versa. And so here's what I do. I use my little scorpion picture to help me remember. So when I'm given this log form, I'm going to use my scorpion, and so I'm going to change it back. And one thing I do to make sure that I'm doing it right is I almost always write two statements just of things that I actually know. And I do know that 10 squared equals 100. All right, and so I know that that is written like this: log base 10 of 100 equals 2. All right, so this is how two things that I know to be true. All right, so when I'm converting from my log back to my exponent form, my log form, I'm going to say 10 squared equals 100. All right, so I just wrote it in: 10 squared equals 100. And I know that's true because this is a statement that I know is true. All right, if I'm given this statement, 10 squared equals 100, I need to rewrite it in the log. I'm going to say log base 10 of 100 equals 2. All right, so I'm going to do my scorpion backwards. Log base 10 of 100 equals 2. So we're going to do some examples and try that out. All right, so the first example we're going to start out with says write each exponential equation in logarithmic form. So I'm actually going to do my backward scorpion. So I'm going to say log base 3 of 243 equals 5. All right, so my log equals my exponent. Notice my log is going to equal to my exponent. Log equals the exponent. Okay, here I'm going to say log base 25 of 5 equals 1/2. All right. Next, I'm going to say log base 10 of 1,000 equals 4. All right. So make sure you learn how to use this because you will be asked to be able to do this. So log base 6 of 1/6 equals -1. Again, remember the log part always equals the exponent. All right, and finally you can do it with variables too. Log base A of C equals B. There it is. All right, try some on your own. Go ahead and turn your video off and give it a try. All right, I don't think you found this to be too challenging. Log base 9 of 81 equals 2. Log base 9 of 81 equals 2. Log base 3 of 27 equals 3. Log base 3 of 27 equals 3. Remember, the log statement equals the exponent. All right, the log statement equals the exponent. Again, here I have to say that x can't be 0 because 0 to any power would just be 0 and it can't equal 1. So log base x of 1 equals 0. All right, the log and the exponent can be a variable. Log base x of 1 equals 0. All right, this time we're going to go backwards. We're going to use our regular looking scorpion. So we're going to say 9 to the first power equals 9. Pretty basic. 9 to the first power equals 9. Here we have 2 to the 9th power equals 512. 2 to the 9th power equals 512. 8 to the 1/3 power equals 2. Just follow your scorpion. 4 to the -2 power equals 1/16. And finally, with variables, b to the 0 power equals 1. And we're going to see that anything to the 0 power equals 1. We know that. All right, any non-zero base to the 0 power is 1. Try these on your own. Turn your video off and give it a try real quick. All right, again, we're using our scorpion. 10 to the first power equals 10. All right, 12 to the second power equals 144. And 1/3 to the negative third power equals 8. Let's just prove that one out real quick. 1/2. I didn't see it correctly. So 1/2 to the negative third. Remember, negative means to do the reciprocal, so that's actually 2/1 to the third power. 2 times 2 times 2 is 8/1 equals 8. So pretty simple. All right, and here's just a little note of rules that you know, but we'll just have them written down, formalized here. When we have the logarithmic of base b, we say b to the 1 power is equal to b. B to the 1 power equals to b. And if you think about that, that's pretty clear. 10 to the first power is 10. Anything to the first power is itself. The logarithm of 1, b to the 0 power equals 1. So b to the 0 power equals 1. And anything to the 0 power is going to equal 1. So just a little note of things that you probably already know, but just should have in your file. All right, a logarithm with base 10 is called a common logarithm. If no base is written for a logarithm, the base is assumed to be 10. For example, log 5 is equal to log base 10/5. You can use mental math to evaluate some logarithms. Let's try an example. Evaluate by using just mental math. So in this first problem, we see log 0.01 or 100th, and we want to find out what that equals. So we're going to say equals x. So we know there's nothing here, so that's an understood base 10. So what we think mentally is we say, well, 10 to the what power equals 0.01. Well, 0.01 is less than 10, so I know it's going to be a negative because it's going to have to be the reciprocal. And it turns out to be, this is 100th, so 10 to the negative 2 equals 100th. And to rewrite it in log form, we would say log 100th equals negative 2. And we know that it's log base 10 of 100th equals negative 2. Here's another example for you to try. On this one, again, we're looking to find out what does x equal. So we're going to think to ourselves, 5 to the what power equals 125. And you can just think this in your mind. 5 times 5 is 25. One more would be 5 times 5 times 5 would be actually 125. And so 5 to the third power equals 125. And then to rewrite it in logarithmic form, log base 5 of 125 is equal to 3. Here's another one to try. Again, we're going to set it equal to x. 5 to the x power equals 1/5. So 5 to what power equals 1/5? Again, 1/5 is smaller, so we can assume that it's going to be a negative. And so all we have to do is 5 to the negative 1 equals 1/5. And so we would write this log 5 of 1/5 equals 1. Just want to point out one more time. Remember, the log is equal to the exponent. The log is equal to the exponent. All right, try this one on your own. Turn your video off and give it a try. Okay, on this one, there's no base here, so we understand that that's going to be 10 and x. So we're going to say 10 to the x power equals 100,000th. So when we do this, we see that this is less than 10, so we know that it's going to be a negative sign on our exponent, and it's actually 10 to the negative 5th. And then rewritten as a log to the understood base 10 of 100,000th equals negative 5. One more for you to try on your own. Turn the video off and give it a try. All right, once again, we're going to set this to equal to x. So we're going to think 25 to the x power equals 0.04. Now notice that this is 0.04, so we know it's going to be a negative, and it's actually just negative 1 because 1 over 25, when you put that in your calculator, is actually equal to 0.04. So to write it out as a log log base 25 of 4/100 equals 1. And again, notice my log statement is equal to my exponent. My log statement is equal to my exponent. All right, because logarithms are the inverses of exponents, the inverse of an exponential function, such as y equals 2 to the x power, is a logarithmic function, such as y equals log base 2 of x. You may notice that in this, when we graph these out, the function and the inverse of our function, that the domain and range of each function are switched. Notice that the domain of y equals 2 to the x power is all real numbers, so that means our x can be anything. It can go on either way. And the range, though, notice that the y can't, in our blue function here, will never pass our x, so the y has to be greater than 0. When we look at our inverse of it, it's going to be the exact inverse. The domain, our x's, can never get past our y, all right? It'll never go past that y, but the x's, the y's of our inverse function can go on in either direction, so it's all real numbers. All right, in this example, we're asked to use the values for x to be -2, -1, 0, 1, and 2. So we're going to graph this function and its inverse and then describe the domain and range. So on this problem, we can see if we make a table out and just fill in with your calculator, when you say 1.25 to the -2 power, you end up with 0.64 and so on, each of those. And so when we graph it, it's going to look like this. Now, in order to find the inverse, remember from our last lesson, to find the inverse, all we have to do is switch our x and y's. And then eventually, it's going to be reflected across this y equals x line. I'm going to just go ahead and do this on the next slide. So here it's written out, our log in log form, and all you have to do is switch our x and y's, and here is our new graph. All right, and when we look at our domain and range for our inverse function, we can see that the domain of the inverse function is going to be, x has to be greater than 0. So notice that my x is never going to get all the way to 0 here. All right, and then the range, the y's, I can have all y's, positive and negative, and so my range is going to be all real numbers. Here's another example. Again, we're going to just make a table, fill it out with our calculator, 1/2 to the x power, -2, -1, 0, and so forth. And then when you plot it on here, we can see what the picture does, or the graph does. And the question tells us to find the inverse. So again, we just have to switch our x and y's. And when you do that, here's what the function would actually look like right here. When we switch our x and y's, we can now graph that. And our graph is going to look like this. Again, it is reflexive across our y equals x line. And now we just have to write our domain and range of the inverse. Now notice my inverse, the x will never be able to get greater than 0. It's going to get infinitely close up here, but my x will never pass that y. So x has to be greater than 0, but my y's, they're going to go on and on forever. So for our inverse of our f of x, the range is going to be all real numbers. All right, here's one for you to try on your own. Make a table in the same way and give it a try. All right, so when we take our 3/4 to the x power and plug in with our table, -2, -1, and so on, we get the following. So let's just review what this said. We took 3/4 to the -2 power. Remember, -2 means to take the inverse, so it's going to be 4/3, and then we're going to square that, so that's going to be 16/9, and that's how I got this answer here. All right, and then when you do all of them, here they are. Plotting it on a graph is going to look like this. And then to do the inverse, we just have to switch our points. It's going to be reflexive across our y equals x. And here it is on the next page. My inverse function, it's going to look like this now. And here there are points again once we switch our x and y's. And there it is. And again, our domain and range for our inverse function, which is our g here. Notice that my x's will never get anything less than 0. So x's are always going to be greater than 0, and my y's are going to be all real numbers. Here's a helpful hint. The log key on your calculator is used to evaluate logarithms in base 10. All right, if you want to do the inverse of it, you can do second log, and that's going to find you 10 to the x power, the inverse of the log. All right, here's a really quick example. Using a food application, it says the table lists the hydrogen ion concentrations for a number of food items. Find the pH of each. Now, I didn't know what the formula for finding the pH, and it turns out to find the pH of each of these, we just have to take the negative log and multiply it by the hydrogen concentration. So let's see how to do that. So let's take milk, for example. And in order to do this, we're going to take our formula for pH, which is negative log times the hydrogen concentration. Just put that in your calculator. You can just type in negative and then log, and then put that number in. And when you do, you end up with getting 6.6. So milk has a pH of about 6.6. Just to do another, I just want you to kind of do these so you get used to using the log in your calculator. Tomatoes, here's the concentration for tomatoes. Again, the formula for pH is going to be opposite, or negative log times the hydrogen concentration. And when you put that in, you get about 4.5. Again, for lemon juice, one more time, put in your concentration, put in your log, and we end up with your lemon juice has a pH of about 2.2. So now I want you to try a couple of these on your own. Turn your video off and try this. Find the pH of iced tea with the hydrogen ion concentration. Okay, so hopefully you were able to do that with no problem. You put it in your calculator and you should end up with a pH of 3.8. All right. I'd like you to just turn your video off and review through this. If you take this little quiz and you find that you still don't understand, you might want to go back through the video one more time and take a look at some of the things. So turn your video off for a second and make sure you can do these problems. All right, so the first one says to change 6 to the 4th power equals 1,296 to logarithmic form. So in this case, we're going to use our backward scorpion. So we're going to say log base 6 of 1,296 is equal to 4. All right. On this one, we have to change it to exponential form, so we're going to go the other direction. We're going to say 27 raised to the 2/3 power equals 9. Should be written like this. There you go. All right, calculate the following using mental math. I'm not very good at mental math, so I'm not really too worried about it if you don't get this big one. But you need to remember to think, okay, this is not x to the 10th power. This is understood 10. So 10, and we're going to put understood an x over there. 10 to the what power equals 100,000. And that is larger, so we know it's going to be positive, and it's actually going to be 5. 10 times to the 5th power is 100,000. All right. The next one we're going to change. Remember, this is equal to x. So we're going to say 64 to what power equals 8. All right. 64 to what power equals 8. And that's going to be a smaller number, actually, which is 0.1 half, or 1/2, 0.5. All right, and then finally, again, we're going to say 3 to what power equals 1/27. I know that's a small fraction, so it must be a negative number. And 3 times what is 27? 3 to the 3rd power is going to be, so it's going to be -3. All right, so I hope you could do that, okay? All right, here's one more for you to try on your own. So turn your video off and give it a try. All right, so hopefully you were able to get these graphed okay. And here's what you should have seen, hopefully. And the domain is going to be x has to be greater than 0, and then for the range, it's going to be all real numbers. So I hope you understand this lesson, and that's the end of the lesson. So have a great day, and I'll see you in class soon. Bye.